Problem number 1. A spring having a length of 500 mm deformed by 50 mm when loaded by 50 kN. A. If the spring is cut by half of its length and is loaded by the same load, compute the deformation of the 250 mm spring. B. Give the spring constant at 500 mm spring. And C. Give the spring constant for the second spring. So, for situation A, we are asked to compute for the deformation of the second spring. So, from the formula of the deformation, we have the deformation 1 is equal to PL over AE. This deformation is due to the applied load. And the deformation is 50 mm. So, we have here 50 mm is equal to the load P, that is 50 kilonewton. So we have here 50 times 10 to the 3 newton multiplied by the length. That length is equal to 500 mm over, so since area is not, we don't have the diameter, right? So we retain this area, and the modulus of elasticity is not given, so this is the modulus of elasticity. So we have here AE is equal to (50 exponent of 3 times 500 divided by 50). So this is equal to 500,000. The unit is Newton. So we have here 500,000 Newton. And we have the elongation too is for the condition of the second spring. So we have here P2 L2 over AE. So we have the deformation 2 is equal to P2. It is the same load, that is equal to 50 times 10 to the 3 newton, and the L2 is this length here, which is 250 mm over AE, and this AE is equal to 500,000 Newton. So we compute for the deformation in this spring, and this is equal to 50 exponent of 3 times 250 over 500,000, and that would give us 25 mm. So this is equal to 25 mm, and this is our answer for situation A. For situation B, we are asked to compute for the spring constant of the 500 mm spring, this spring here. So we have the spring constant of first spring. Spring constant of the first spring, we know that the spring constant is equal to P over the deformation, and the P is equal to the load, that is 50 times 10 to the 3 newton over the deformation, and that deformation is equal to 50 mm. So we have here over 50 mm, and that would give us the spring constant of the first spring, which is equal to 50 exponent of 3 divided by 50, and that is 1000. The unit is Newton per mm, and this is the answer for the second situation. The third question is, what is the spring constant of the second spring? So this spring here. So we have here K is equal to force over the deformation 2. So the force here is 50 times 10 to the 3 newton, and the deformation here is equal to 25 mm. So we have here 25 mm. And computing for the spring constant of the second spring, that would give us 50 exponent of 3 divided by 25. And this is equal to 2000. So we have here 2000 Newton per mm. And this is the spring constant of the second spring.